Hello students, in this video we will learn about definitely motion. What is motion? When an object covers some distance with respect to time, or when an object changes its initial position, that is the motion. So I have a question for you. What is motion? Now look at all the pictures. Definitely all the pictures are the examples of motion because they changes its initial position with respect to the time. Okay, now come to the next slide. What is exactly motion? Motion is defined as the change in position of body with time, but for describing the motion we need a reference point, and this reference point is called the origin. मोशन को एक्सप्लेन करने के लिए हमें एक ओरिजिन की ज़रूरत होती है. सो लुक एट द origin, that is A, and which is also called initial position. Now from this initial position, this smiley covers some distance from path 1 and goes to its final position, and another smiley covers some distance and goes to that same final position from the path 2. What is the difference between path 1 and path 2? Here path 1 is the distance and path 2 is the displacement. You know the difference between distance and displacement? Distance is the scalar quantity, but displacement is the vector quantity. Distance is the actual length covered by particular object, but displacement is the shortest distance between initial position to the final position. So here for first smiley, path 1 is the distance and path 2 is the displacement for first smiley. फर्स्ट स्माइली के लिए अगर हम बात करते हैं तो पाथ 1 इज द डिस्टेंस, बट पाथ 2 उसके लिए डिस्प्लेसमेंट होगा, बिकॉज पाथ 2 इज द शॉर्टेस्ट डिस्टेंस बिटवीन ए एंड बी, एंड अकॉर्डिंग टू डेफिनेशन path 2 is the displacement for first smiley, but for the second smiley, that is green smiley, path 2 is the distance as well as the displacement, because path 2 is the actual length covered by the second smiley, and this is also the shortest distance between its initial position to the final position. You got it? Distance and displacement. Okay, now there are some terminologies which is very useful for this chapter. And first terminology is rest position. What is rest position? When an object does not change its initial position with respect to the time. यदि कोई ऑब्जेक्ट अपनी जगह पर स्थिर रहता है उसे हम रेस्ट की पोजीशन पर मानते हैं. टाइम बीतते जाता है बट वो ऑब्जेक्ट अपनी पोजीशन को चेंज नहीं करता है. नाउ व्हाट अबाउट मोशन? डेफिनेटली when an object changes its initial position with respect to the time, that is the motion. यदि कोई ऑब्जेक्ट अपनी इनिशियल पोजीशन को टाइम के साथ साथ चेंज करता है, दैट मीन्स वो ऑब्जेक्ट मोशन में है. नाउ कम टू द डिस्टेंस. एग्जैक्टली द एक्चुअल लेंथ The actual length covered by an object is the distance. And distance is the scalar quantity and its SI unit is the meter. What about displacement? The shortest distance between the initial point to the final point is the displacement. And displacement is vector quantity and its SI unit is again meter. What is the difference between scalar quantity and vector quantity? Those quantities having only magnitude, is the scalar quantity, but those quantities having magnitude as well as direction is the vector quantity. This is the difference between scalar quantity and vector quantity. Got it? Okay. Now come to the uniform motion and non-uniform motion. What is uniform motion? When an object covers equal distances in equal interval of time. यदि कोई ऑब्जेक्ट इक्वल डिस्टेंस कवर करता है इक्वल इंटरवल ऑफ टाइम पर, दिस इज द एग्जांपल ऑफ यूनिफॉर्म मोशन. And look at the picture. From point A, and we assume this point A is the origin, and this smiley covers 100-meter distance in 10 seconds from point A to B, and again it travels distance that is 100-meter in 10 seconds from point B to C is the example of uniform motion. यदि कोई ऑब्जेक्ट इक्वल डिस्टेंस ट्रेवल करता है इक्वल इंटरवल ऑफ टाइम पर, वो यूनिफॉर्म मोशन कहलाता है. इज दैट क्लियर? ओके. नाउ कम टू द नॉन यूनिफॉर्म मोशन. When an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. सेम इक्वल इंटरवल टाइम होगा, बट जो डिस्टेंस कवर किया जाएगा उस ऑब्जेक्ट के थ्रू वो अनइक्वल होगा. लुक एट द पिक्चर. फ्रॉम पॉइंट E, दिस स्माइली covers some distance that is 150 meter in 10 seconds, but from point F to G it covers 100 meters in 10 seconds. Here this smiley covers different distances in equal interval of time, and that is the example of non-uniform motion. Look at the table for uniform motion and non-uniform motion. In uniform motion, distances are equal as well as time interval are also equal. But in the case of non-uniform motion, distances are unequal but time interval are equal. But for measuring this motion, we know some of the objects are fast and some of the objects are slow, like cheetah, like plane, like car, like dog. Some of them are moving fastly and some of them are moving slowly. So by seeing, we find which one is fast and which one is slow. So we need a quantity to measure the rate of motion. So this quantity is the speed. Now look at the picture. Car is the fast moving and dog is the slow moving. So we need a quantity and this quantity is speed. So what is speed? The distance traveled by an object in unit time is referred to as speed. Or we can say the ratio between distance upon time taken is the speed. What about average speed? The ratio between total distance and total time taken is the average speed, just like a mean. Okay, now come to the velocity. Velocity is related to the displacement. That's why velocity is the vector quantity, and velocity is represented as displacement upon time taken. What about average velocity? It is given by the arithmetic mean of initial velocity and final velocity for a given period of time. So we have two velocity, that is u and v, where u is the initial velocity and v is the final velocity. So the according definition, u plus v by 2 is the average velocity. Come to the acceleration. The rate of change of velocity is termed as acceleration, and it depends upon the velocity. That's why it is a vector quantity and its SI unit is meter per second square. And the formula of acceleration is v minus u by t, where v is the final velocity and u is the initial velocity. There are three types of acceleration, that is positive acceleration, negative acceleration, and zero acceleration. Negative acceleration is also called as retardation or deceleration. Is that clear? Okay. Acceleration के हमारे पास कितने टाइप्स हैं? 3 टाइप्स है, that is positive acceleration, negative acceleration and zero acceleration, and it all depends upon the velocity. ये किस पर डिपेंड करते हैं? वेलोसिटी पर. And which type of velocity? That is initial velocity and final velocity. Now come to the positive acceleration. If final velocity, that is v, is greater than the initial velocity, that is u. Now look at the example. Here u is equals to 10 meter per second, v is equals to 25 meter per second, which is the final velocity. And here, according to positive acceleration, final velocity, that is v, is equals to 25 meter per second, which is greater than the initial velocity, that is u is equals to 10 meter per second square. And according to acceleration, that is v minus u by t. What is the value of acceleration? That is 25 minus 10 by 2, that is 15 by 2 is equals to positive 7.5 meter per second square. This is the example of positive acceleration, which gives us positive acceleration, that is positive 7.5 meter per second square. What about negative acceleration? It is just opposite to the positive acceleration. A final velocity, that is v, is smaller than initial velocity u. Now look at the example. Here final velocity v is equals to 10 meter per second square is smaller than that of the initial velocity, that is u is equals to 25 meter per second. And according to acceleration, we calculate the acceleration, and the acceleration is negative. According to definition of negative acceleration, here final velocity is smaller than the initial velocity. So we have negative acceleration, that is minus 7.5 meter per second square. This is the difference between positive acceleration and negative acceleration. Got it? What about zero acceleration? Think about that. In positive acceleration, we have final velocity is greater than initial velocity, and in negative acceleration, we have final velocity v is smaller than initial velocity. What about zero acceleration? Exactly. final velocity v is equal to the initial velocity, that is u is the zero acceleration. जब फाइनल वेलोसिटी और इनिशियल वेलोसिटी दोनों ही इक्वल हो जाएगी तो वो जीरो एक्सेलरेशन होगा. Got it? Okay. Look at the example. Here u, that is the initial velocity, as well as v, that is the final velocity, are same, that is 25 meter per second. And according to acceleration, that is v minus u by t, what we got? That is 25 minus 25 by 2, that is 0 meter per second square. This is the example of zero acceleration. Now, what about uniform acceleration? Uniform acceleration कब होगा? When velocity of body changes by equal amounts in equal intervals of time, acceleration is said to be uniform. For example, motion of a freely falling ball. This is the example of uniform acceleration. What about non-uniform acceleration? When velocity of body changes by unequal amounts in equal intervals of time, acceleration is said to be non-uniform. For example, motion of car. So this is the examples of uniform acceleration and non-uniform acceleration. So uniform acceleration and non-uniform acceleration. Now come to the graphical representation of motion. There are so many graphical representation which gives us speed as well as acceleration. Okay, so first graphical representation of motion, that is distance time graph for uniform speed. You know about uniform speed? That is distance time graph for uniform speed, which gives us a straight line. Now look at the picture. In horizontal axis we take time in second, and in vertical axis we take distance in meter, and the relation between distance and time is the speed. And according to first graphical representation, we take a straight line. Now look at this picture. This is the straight line. Okay, at point A, time taken by an object is 2 seconds and distance covered is 3 meter. But at point B, again 6 minus 3 is 3 meter, and time taken by that object from A to B, that is 4 minus 2, is again 2 seconds. So this is the example of distance time graph for uniform speed. What about distance time graph for non-uniform speed, which gives us curve, Now look at the example. Again we take a coordinates of x-axis and y-axis, that is horizontal axis and y-axis, where we take time in horizontal axis and distance in vertical axis, and we got a curve in the case of distance time graph for non-uniform speed. Here at point A, in 3 seconds object covers distance, that is 1.8 meter, but at point A in 2.4 seconds 2.2 meter. This is the example of non-uniform speed, which gives us a curve. Now come to the third graphical representation, that is distance time graph for a body at rest. What do you think when a body at rest. That means that body does not covers any distance when time passes. यानी कि अगर कोई बॉडी रेस्ट में है तो वो अपनी पोजीशन को चेंज नहीं करती है, टाइम कितना भी पास हो जाए. एंड वी टेक डिस्टेंस इन वर्टिकल एक्सिस एंड टाइम इन हॉरिजॉन्टल एक्सिस. और यदि कोई बॉडी रेस्ट में है यानी कि वो डिस्टेंस ट्रेवल नहीं कर रही है तो डिस्टेंस कांस्टेंट हो गया है बट टाइम पास होते जा रहा है. दैट मीन्स द लाइन which gives us for a body at rest is parallel to the horizontal axis. ऐसी बॉडी का जो हमें लाइन सेगमेंट मिलेगा वो हॉरिजॉन्टल एक्सिस से पैरेलल होगा. नाउ लुक एट द पिक्चर. इफ एनी ऑब्जेक्ट which moves from 0 point to point A, it travels or covers some distance, but from point A to B, time passes from 2 seconds to 5 seconds, but distance remains constant. यहाँ पर A से B तक में हम जब देख रहे हैं तो यहाँ पर डिस्टेंस इंक्रीज और ना ही डिक्रीज हो रहा है. दैट मीन्स this object is at rest and the line segment for a body at rest is parallel to the horizontal axis. Now come to the fourth graphical representation of motion, that is velocity time graph for uniform acceleration. अब हम यहाँ पर यूनिफॉर्म एक्सेलरेशन की बात करने वाले हैं. वेलोसिटी और टाइम का जो रिलेशन होता है वो हमें क्या देता है, एक्सेलरेशन देता है. यहाँ पर जब हम बात करेंगे वेलोसिटी टाइम ग्राफ फॉर यूनिफॉर्म एक्सेलरेशन, इट ऑल्सो गिव्स अस अ स्ट्रेट लाइन. नाउ लुक एट दिस पिक्चर. लुक एट पॉइंट ए. Velocity is 3 meter per second and time is 2 seconds. But at point B, velocity is 6 meter per second and time is 4 seconds. Now, we explain more clearly. We take some cases for that particular example for point A and point B. Now, this is the first case. From initial point, that is 0, where the coordinates of that particular point is 0 and 0. 0 से A तक के लिए अगर हम बात करते हैं तो initial velocity at point 0 is 0. And 0 is the initial velocity. What about point A? That is the final velocity. And what is final velocity at point A? That is 3 meter per second. And time taken? Exactly 2 seconds. जो हमें कहाँ से मिल रही है, हॉरिजॉन्टल एक्सिस से मिल रही है. So, according to the acceleration, what we have, acceleration, that is 1.5 meter per second square. And this is the second case from initial point. Now come to the point A, where initial velocity is 3 meter per second, but the final velocity v at point B is 6 meter per second, and time again 4 minus 2 is 2 seconds. So the acceleration, that is 1.5 meter per second square. Here, in both the cases, acceleration is 1.5 meter per second square. Look at this. Both the acceleration are same. Both the acceleration are same. 1.5 meter per second square according to acceleration. And what is acceleration? It is v minus u by t. So according to this acceleration, in both the cases, acceleration is 1.5 meter per second square, and this is the example of uniform acceleration. Now come to the fifth and last graphical representation of motion, that is velocity time graph for non-uniform acceleration, which gives us zigzag line as shown below. In the case of uniform acceleration, we have a straight line, but in the case of non-uniform acceleration, we have a zigzag line. Look at this picture for non-uniform acceleration. जब हम नॉन यूनिफॉर्म एक्सेलरेशन की बात करते हैं तो जब हम उसका ग्राफिकल रिप्रेजेंटेशन देखते हैं तो यहाँ पर हमें एक जिगजैग लाइन दिखती है। जैसे हम देख रहे हैं कि ओरिजिन 0 से ए तक की एक स्ट्रेट लाइन जा रही है, बट नॉन यूनिफॉर्म एक्सेलरेशन होने की वजह से ये एक स्ट्रेट लाइन ना होकर क्या मिल रही है, हमें एक जिगजैग लाइन मिल रही है। 0 से ए तक स्ट्रेट जा रही है, फिर डाउनफॉल हो रहा है, फिर इंक्रीमेंट हो रहा है. So this is the example of non-uniform acceleration. So what we learn in this video about motion, about speed, about velocity, distance, displacement, difference between distance and displacement, their units, as well as graphical representation. Thank you for watching this video.